Hi, my name is Chris Freeman, and I want to talk to my students today about the living world. So this is helping them hopefully study for their upcoming AP exam. And I want to start by talking a little bit about the difference between abiotic and biotic factors. So biotic things are going to be living organisms, plants, animals, that sort of stuff. And abiotic factors are going to be like rocks, water, um, that sort of thing, air, things that are non-living. So we all have abiotic and biotic factors in our lives, and it's important to know the difference between both of those for the AP exam. So what we're looking at here is the law of tolerance, and every organism has a niche, an area, a zone of which they can live, and there's different factors that allow them and help them live. Temperature is certainly going to be a factor, available food, and precipitation, water, how much water is a part of their life. And within that zone of tolerance, you're going to have a fundamental niche, and this is sort of where you're able to live, and then a realized niche, which is, you might have some other factors going on, other organisms that are fighting for space and forcing you into a tighter space within that entire fundamental niche that you could live. You get reduced into this tinier space. So it's important to know the difference between a fundamental niche, the entire space within the law of tolerance that you could potentially live, and then this realized niche, which might be a little bit smaller. And so there's some thresholds that you need to think about. If you have too much water or too little water, you're going to be in trouble. If you have too much heat or too cold, you're going to be in trouble. But you can live on the margins of these zones and still be able to thrive. So, or at least make do. And so this is something to think about a little bit, because within this, you might be a specialist, right? And if you're a specialist, and for some reason there's a change within your niche, you might be in real trouble. Specialists are incredibly good at catching food, surviving in this exact ecosystem of which they have. But if that ecosystem changes, they can't cope, and that usually means they die. Humans, for some reason, love specialists, football players, musicians, someone who's really good, mathematicians, right? Someone who's really, really good at something. We put them up on a pedestal. But in the world of nature, and really in humanity too, it's better to have multiple things that you're pretty good at than just one thing that you're just so super amazing at. And so, maybe the raccoon is something that we need to celebrate more as being a generalist, and that we should all aspire to be, some sort of scrappy little raccoon that can adapt to multiple different environments and live within this changing world that we have. Um, and so competition does affect how you live in this zone, in this ecosystem, in this niche that you're making for yourself. And you have intra-specific competition, which would be you competing against other organisms that are the same species. And then you have interspecific competition, and that's when you have different species competing. And there's competitive exclusion principle, which basically means that if there are multiple organisms fighting for the same niche, then one of them is going to win, and the other's going to die off or have to move into another zone, another area. And so these are all factors that sort of establish where your niche is and what it is that you do. And this is important stuff to know. These are important terms to know and think about for the AP environmental exam. So this law of tolerance is something to think about as you're going through the exam, thinking about shifts in ecosystems and niches. All right, I want to talk a little bit about predator and prey relationships. Here you see a really nice graph depicting, and this is a little generalized, but you see the lynx and the snow hare and their relationship. And if you look at the lynx, it is lower in quantity. There's less lynx on this graph than there are hare. And the reason for that is because the hare is the food of the lynx. And so you need to have a lot more hare in order to support the growth of the lynx. They might eat multiple hare per day or week, and that is critical for there to be more hare in order for the lynx to survive. And you can see as the hare number drop, then there is a lag and then a fall of lynx population as well. When the hare rebound, the lynx can rebound. But there's this relationship that's a predator-prey relationship where there is some regulation of um, um, the growth of the snow hare, that this predator keeps them in check to some degree. But there's definitely going to be have to be more food than there are lynx, so that the lynx can have enough food to eat. All right. So we have other things aside from just um, predator-prey relationships. We have mutualism, commensalism, parasitism, and these are terms that you need to know. One that I think is a little less common um, for people to think about is commensalism. Um, and here you see a cattle egret um, waiting around in the grass, not bothering the cattle at all, um, waiting for the cattle to kick up some grasshoppers. When the cattle are on the move, it startles grasshoppers, and the grasshoppers jump to get out of the way, and the egrets are right there ready to catch them. So the egrets benefit from the cattle, but the cattle they don't really even notice the egret. They don't benefit or get hurt at all by whatever the egret are doing. So that is the base. That's a great example of commensalism there, because one organism's benefiting, but the other organism, doesn't really matter. All right, so let's look at another important thing to understand as a component of this living world unit that you need to know. And this is keystone species, right? So you need to understand that if a keystone species is removed from an ecosystem, then you have the ecosystem collapse. So wolves are a great example of a keystone species. In a forest, they will regulate deer populations. I think about Aldo Leopold for that. And the reading of the killing of the wolf. If you eliminate all wolves, then deer uh, don't have anything to keep them in check, and they grow and then die of their own too much excess of eating, and then as a result of that, the mountain that the deer are on has too much erosion because the deer eat up all the vegetation, and so there's this real collapse and interconnectedness of this entire ecosystem that depends on this predator. And another great example of this, if you look here, the otter. And so um, otter are going to be the keystone species in a kelp forest. And they feed on urchins, as you can see here. And so if I just scroll down a little bit, this is a kelp forest, and urchins will eat the base of the kelp until it breaks away and just drifts off. That's their preferred food. And so if you have an overwhelming amount of urchins, then the entire kelp forest goes away and you're just left with the urchins. And that's going to happen if you don't have a top predator. And so here we see a great example of a top predator doing its thing, eating up a bunch of urchins so that it can remain happy. So I'm going to stop there. We're going to be moving on to looking at how energy transfers through our food web next. But this is the living world and a good little quick review for that content. Hope you liked it.